Good morning. No signals yet. Good morning, everybody. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, February 15, 2022, Tuesday, 3:30 a.m. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक फरवरी 15, 2022 मंगलवार सुबह के 3:31 regarding talks, continuation of talks about title Quality, Project Works, Coordination World, Communication Network, Concrete, Civil Field Engineering, Reliable Engineers, Work Contracts, Safety, Science, Construction Methods, Claims, Organizations, etc., etc., Estimate, Quality and Coordination, and my email ID, you can say suraj_engineer@yahoo.co.uk. You can use it if you are interested, if you have any question or you want to raise some question or you want to make some talk. Certification of Chartered Engineer India and certification of fellow membership, fellow of Institution of Engineers India, and also quality description file, and here is coordination description file. These certificates I try to show every day because people know what are these. These files are also like now indications of competency, and we have to be very careful about these certificates, that there are certificates, there are processes available for competency, and this is that one. Now I am closing this FI certificate. I was closing C certificate and continue to speak about quality and coordination and also coordination engineering. These two files, that is quality and coordination. If I just hide this line, it's quality and coordination for all. And if I keep just like this, it's an exclusive talk on Bharat India that speaks about quality and coordination, because as a nation we have to speak. And here is what I say: coordination engineering, which is not as a nation, but is a requirement for entire humanity, entire world. Coordination engineering, projects and engineers, because ultimately it is projects. Is it engineers who are affected, who are involved for world of coordination, and that moves on wheels of communication. We can say for reliable quality engineering works, deliveries, it's kind of note. As such, it's also a kind of note, quality and coordination. And we can say get up quality and get up coordination. Do not sleep. Sleep is not our objective. Sleep is not an individual's objective, and sleep is not world objective, society objective, nation's objective. And sleeping is different one. It's not physical sleep, but awareness is sleep, application is sleep, not doing your job sleep, or you can say it's kind of different sleep. So my sleep is not applicable, and it is also true that I cannot work in my profession without quality and without coordination. And also it applies to everyone. I am friend of quality, I am friend of coordination, and of course I am friend of these two. That's why I am friend of good work. I am friend of quality work, quality production, quality manufacturing, quality construction, quality conduct, quality service. Quality, you can change this world into quality one, because God or whoever is responsible for this world as a quality soul, as a quality conduct, arrangement, designer. And we can't deny that fact. God knows quality very well. God knows coordination very well. And that's why I say quality, you are with me, you have to be with me, You can't go otherwise, you cannot live. This is my control statement. Because if I work quality, if I dispose quality, if I move with quality, quality cannot go. And that's my commitment, that's my control on myself. And when I say I control on myself, then everybody should say that I control myself. This means everyone controls self, and that control is very important. And the control is what? Control. It's not smoking or drug consumption or something else, is anything else. It is work. It is work and all works. Quality is defined or it is not defined, it is assumed, or it is selected or elected, or you can say you accept yourself. So my destiny lies in quality status, my destiny lies well coordinated, and my destiny I have to decide, your destiny you have to decide. And of course you can say when we work sincerely, we have some good objective, we have to achieve that objective. That objective at one time becomes destiny of person, and you involve your totality into that objective to achieve it, and that is very important focus we have to understand. If we don't have any objective, we can't move to get that destiny because we do not know destiny. We do not know where it is, and destiny is very important in life, or we can say in ordinary language, ambition is very important. Ambition doesn't mean to get some position, ambition means to do something for this world, to which we have come for a certain fixed journey. And if we don't do that, then we don't respect this world. We don't respect that power which sent to this earth. We sent everybody to earth, and we as a part of nation and therefore as part of world must respect this good work, quality work, good communication, good coordination, because all these are used directly or indirectly somewhere. And best community is, best performer should be engineer. For engineer is educated, professionally, technically, work-wise, experienced, and it is that professional who can handle quality successfully, who can handle production successfully, and who can give society what society gave to that person to have education and to develop as engineer. Once you develop your personality as engineer or doctor or professor or whatsoever, it becomes duty of that professional to help society, to help itself. I am not saying you do any obligation, you do some obligation by helping society because that is your fundamental duty, because society brought up you that level. And you have to do something for that, not for just for money, but for helping this world to become more better, for which we have all assumedly come here. And that's why I say we require you quality, coordination, and good work established here permanently in engineering profession and also all other walks of life, which is very important. Performance should be quality based, performance application should be quality based, and quality as such a substantive should be there, because quality has every location. There is no particular place for quality and coordination. These work everywhere all time. It may be whatever, procedures of designs or manufacturing or construction or whatever else. We have to be with that, that has to be with us. That's what we say. It's really wonderful that if I say we have to fix quality in our country, come what may, and when we say come what may, it means something. And we also say come what may, and there should be no excuse for concession, and there can be no excuse for concessions. Why concessions? When you have to deliver you, what there's no meaning of any concession, and concession applies to certain contracts but not to life. So we have to fix you and you have to fix us both. I know you are not an entity, but you are an existence. It's not an entity. You are. I don't want to drop you. I don't want to degrade you. Your existence, your permanent existence, because you are a part of this world. I am not part of this world. I am temporarily part of this world, but you are permanent part of this world. There's a difference of understanding. Work quality cannot be compromised. There is no way. We cannot even imagine to compromise quality, that is imagination, but practically, if you see ground, it's not, it doesn't work. And therefore, we do not intend to compromise just in name of system of quality or quality system, which actually is fragile because it doesn't have solid cover. It is only casing that can resist impact of hammer that tries to break quality, and we have to be very careful about that. Fragile existing quality system compliance formality etc. are not required, but what's required is product. Product, we say, systems may fail, but work may not fail, quality may not fail. That is requirement. So we are not bound by system, we are not slaves of system. That's also true, but we design system, therefore we respect system. It's not inter-universal design, it's our own design, designed by certain institutions and designed by certain people, and this must be respected because we are responsible for that we do. And if we don't maintain this, then we don't maintain our own work, and that is self, you can say self-rejection, and self, you can say defeat. We have to think about this, and we have to come back to the coordination, which is a current issue for us, and we say engineers, reliable quality engineering works, as I said, projects and engineering. For some people, because I have tried many searches on Google or others, I could not find any you can say concrete material about coordination engineering, except one or two or three sites I could get, but that were not also very much supportive, and I can say that I couldn't find that. These are certain, I can say again for reference, there is some few projects. I'm just going to very fundamental talk, and that's about coordination and quality, and that's what I can say here is now. We're going to coordination engineering is a must in every project, and every project. Nobody can deny this fact who deals with projects or who deals with in life with very small projects also. Coordination is something that cannot be avoided, and we have to respect that coordination. Come what may, as I said, come what may is very important point here because of quality issue and because of coordination. So coordination engineering and quality are interrelated because one helps others. If there is no coordination, there's no, this means there is no communication, and communication doesn't mean formal communication through mobiles or through conversation or through messages. It is communication that is engineering one, means it depends on designs, drawings, construction. So we can say on every project that this, I'm just trying to read it so that you can refresh it, and I had also added something, and that BMI and that we have BIM system. Also we have got yesterday some discussion. I'm going to try refresh and move further because every day I keep on changing something. It's under construction, this file, yet it has progressed well, and where shall it stop, I don't know, because I did not find a very reliable material, only very fundamental material. But what actually happens, I don't say you have to change to software of coordination, because I don't think that's where software always cannot work. But mind can work and experience can work. We cannot inculcate experience, we can convert experience into system of software. That's not workable, because when you say experience, every project has different experience, every project has different design, every project has different inclusions of different varying disciplines of engineering, and therefore I cannot say that you can say projects are typical. Projects are typical in nature of material consumption or material of maybe in designs, but as far as quality is concerned, coordination is concerned, it's not same. Principle may be same, but contents may not be same. So I say coordination engineering we have to define in various ways, but first we have to understand what is coordination engineering, and that is important point for every fresh engineer, every student of engineering I should say rather than that. And not only student of engineering, student of schools and universities also, they should understand what is meaning of coordination. Because coordination based on communication, it works everywhere. We have to help communication, and communication means we have information transfer, means we have information because of communication, and that information is no meaning if we don't interrelate various information together. Various informations must be interrelated and understood, and that mix of information, if we understand each information, which we can say this is applicable to this work or not applicable to this work. If it applies to this work, means that is valid, that is useful. And there may be hundreds of information with us, but none applies to that activity. Means those information are off track from that. May be suitable somewhere else, but not in this. So that communication part cannot support my coordination. But we say we do engineering projects, and every engineering project, it may be a design project, or it may be construction project, or manufacturing project, or whatever project it could be. Communication is important and coordination is very important. If you use these two, communication is of course you have to use, there is no other way, because you have to use referral documents, and referral documents, design documents, drawing documents, specification documents, and you have to see whatever else documents, and also you have to see your own documents. These are documents of designs, and of course when you may get your own documents extracted from these documents. Likewise we can say, and whatever way you adopt to do that, so you can say it all depends on various interlinks of communications and your own communication, and then you have to make sure that all this communication tell you what you have to do, and if you decide what you have to do, and that is an important point. And if you can write that for others, it's also called a super related communication, because your communicated work is being communicated further to others. So you can say every act is communication, every result is communication. If you are, and there's no end to communication, there's no other communication, or you can say communication is always, it's at end works as coordination, because you checked all communications, you got extracted certain information, reliable information which is useful for you. And that's why it's very important point that this in summarized form I explained what is coordination. And coordination means a kind of equality of all people involved on one item or one project or one design or whatever it is. You can say we are all equal, not different, we say, but we are all responsible. If you make good coordination, it's good product and it's good result. If you do miscoordination, means there are some lapse, and it takes time to extract or to discover that lapse, and that's where we can say quality has lost somewhere. Maybe by 1% or 2% we lost quality, and then when lost quality means you feel very bad, why did I lose quality? Despite my efforts, despite everything I did, but I lost my quality, and that's the point we had to be very serious about it. That's why we had to understand definition of coordination. There's no meaning of explaining communication, because everybody knows what is communication, and communication is not particularized, it's general one. Every medium is used, every communication form is used, every platform is used, every system is used. It may be mobile, it may be electronics, it may be computers, it may be web, or you can say whatever way you can communicate, by talk, by writing, by verbatim, or by eye signal, or whatever. You can say your own way of communication with your family, with your neighborhood, with your country, with your professionals, with the public, and of course with yourself. That's very important, yourself on. And that's very difficult to understand, how to communicate to yourself. If you cannot communicate to yourself, I'm sorry, you cannot communicate very well, because in yourself you have to place someone, some entity other than yourself. If you can talk to you, people just say you talk to yourself, you'll get a better answer, you get better response, because when you talk to yourself, your own questions can be answered by you itself. Your own questions Your own questions, your own doubts can be rectified by you only, can be answered by you if you are intelligent person, because they are so much importantly hidden in you based on your experience. Sometimes you forget what's hidden, and when question goes there, you can get answer. Therefore, you can say it's also kind of communication. It's actually, you can say, very refined form of communication. So what we have to understand is, say, we say, for example, here is written, designs, construction, controls are very interrelated, required sections for achieving from successful start to completion of a project, which all must be applicable throughout project stages, with all works be smoothly affected. And because here we are referring to all project stages, means which are from beginning or from commencement to complete testing and handover, and that's what is a design is involved, construction is involved, controls are involved. There's no one set of design. There's so many disciplines are involved in one design, so not one, depending on type of project we do. There may be lot projects we may not require that much design. There may be some other projects, you can say, which are only superficially done, but projects where space is involved, means volume is involved. For example, building work or plants work or vertically important work or horizontally important work, or you can say where mass volume works, so where quantities are high, and you can say many miscellaneous types of works are there, where structures are involved everywhere. So designs are very important for that, and designs may be all designs. It's not simply from conception stage. You can say even at time when you think of some project in your mind, I have to do this project, I have to develop this city or nation. From beginning itself, you can say that comes into play in whatever form, feed design or pre-feed design, or you can say working designs, or before working detail, or the schematic design. So if we can say, let us say inception design, some dream comes to your mind, and that dream say, I have to do this, a government thinks, or some public sector thinks, or some people think we have to do this, we have to produce something like that. You can say that is initial design, conceptual design, or imaginary design, or you can say it's a kind of mirage, or it's kind of something which is not available, but you have to get that, and you have location of that as well in your mind. So we can say we can jump onto designs. There's feed one. This was pre-feed explained to you. That's feed one, FEED, which stands for front-end engineering design, and that means it's a kind of grassroots design, where you can say it's like a wood, a forest where nothing is organized, but everything is available, and you have to decide which one we have to use. So you can say that what is your education, is complete information you have, but which information you are going to use, that depends on what type of work you are going to do and what you expect from your own knowledge, and which formula you want to apply, or which is scientifically or engineering wise applicable. And we have to understand that. That's why it is a feed is very important part. Those who understand feed, they know a lot, because feed is not raw one, it's very much, it's a kind of bank, feed, what you can create a bank for your project. These are so many options for designers. You have to extract whatever required all based on this, and this is a procedure we are going to apply, and this is a formula we are going to apply for this. So this is element or component of product you have to produce for this project, and there may be hundreds such components in every project, and they are to say every component is required to be designed for principles, for use, and for you want to exercise. You can say this must, this intends to do. I have the intention that I should do this. English very good sense, and that's, you can say we have to do a feed work on that. It's not FEED, feed as a verb, but it's a feed as abbreviation, FEED. Don't confuse with feed or feed spelling. It's FEED means not that which we have to feed something. No, it's FEED is abbreviation, is front end engineering design. Means in the front end we are here, then we have to go to rear end or to back end. You can say, if you talk horizontally, if you go to vertical, that's different one, that is space design. So every design is space design. We cannot say otherwise. So say at front we stand here, what we have to do, we got some plan, we have got some dream in our mind, and that's pre-feed, and our feed starts, and you have to think how many components are there in this design. Possibly there are so many components. How this components has to, because we have to think of complete design what we are going to produce, and for complete design we have to write some method, or we have to direct someone which theory shall be used and which formula shall be used, and what we want to expect that this components to perform on this, and we have to see that this performance must be suitable. This performance must work, and if the performance, which formula we have to use for this performance satisfaction. All for thousands of formulas available in engineering designs, particularly in structural engineering design or civil engineering designs. You can say, so much is available as information, so much can be calculated using direct calculation, software-based calculation. we can say we have a lot of that, and we can say, okay, fine, we have this, and now we say the field designs, and we have covered generally all components, major components, and we have included with this should be designed accordingly using this formula or this way, whatever we say, normal or normal, and then out of this, this is job of the executive designer who designs based on feed you design yourself. And also it's not simply work calculation, it's not simply structural design. Important part is technical design, you can say procedure design, or you can say application design, or you can say requirements design, how we can satisfy, how can produce satisfactory work based on, and which way it is to be done, and we have to describe that in written form. It's kind of some specifications, we call it. Specifications mean particular activity, means we have to do. It's not general one. So there are general specifications by title, there are project specifications also, because spatial, which all should be in generalized form. If general specification is specific one, or they can say particular for every particular project, you can say particular specification. There can be specific items, not generally all, but maybe say 10% or 15% items, which are very much particularized, which are very much project oriented, and those must be described separately. Those must be given complete reflection, what is required scientifically, what is required engineering wise, and there's an object to do this, and how this object can be attained in that kind of specifications must reflect, means what you have to do. And that's really very important part of coordination. In design, I'm saying design coordination means how designs are related and correlated. It's not only that you have to use BIM, but as you can say, it's not simply BIM, but you have to, you say your own BIM in your mind, means it's not building information model. No, it's not that, but that is inside your mind. That's building information model, because gradually we are finding ourselves used to be slaves of software, but we have to use our own software in some mind, because that's much better than generalized one. And that's why it's a general specification is one part, just like general drawings are one part. We say general arrangements drawing is just like entitled drawings, right? Said general arrangement drawing of this level, general arrangement drawing of this level. Then we go to some other title, it's not general plan or general light, and we specifically name something, general details or whatever we can say. This depends upon designer, what best way you can communicate to user on site of these designs. So what you understand by that. General terminology can be given in notes on drawings, what consideration you have made, how we have considered general layout or the specific layout or elevations or sections or plans or whatever it is, or perspective, or you can say which software is best for you in this design. Means there is another way. I'm not going to that. I'm just saying that design, construction, controls. I talked about designs, but designs what you produce doesn't mean shall work directly. First, you have to understand your design. That's first important. Means you have to think the design you produce is going to. If suppose you do yourself on site, how is it worth? That's what I say. Means. If there is a constraint on designs itself, it may not work. It may not be working. It may raise questions. Means a person who works on site doesn't want to do wrong work. Nobody wants to do wrong work, because they have to spend efforts, they have to spend money, they have to spend material and time and everything. Who shall like to say my job should be wrong, my job unacceptable? Nobody would like to say that. So that's the point. A designer must first consider at its own level, is one capable to run this design in construction. That's the important part, where design itself is a question of analysis. This means design is very important part, and we have to think in that term. Is it worth construction or is constructable? And if I know it has some problem, then if you say it is a problem, certainly site person will say there's a problem. And that problem, what is that problem? You should know. If you are a designer, you must know if you are having this problem and you don't have any solution. In that case, you have no right to do that design and release it until you get solved all those problems. Design drawings itself are very communicative. There's no one-page design. There may be hundreds and hundreds of pages of design. And many pages will be different and many would be linking together. And those are linking, fine, you can link them. And those who are not linking, there's a question mark. How shall you do that? First of all, you have to see that that's compatibly fit or suitable with each other. All pages talk to each other, they understand each other. That's very important part. So you can say design itself is a detailed you can say coordination that we have to understand. And once the design stage is crossed, then construction is just comes in, and in between construction and design there's another stage that's called processing, process, bidding process. If you have to award some contract, if you have to give this work to some contractor, or you have to do it yourself, that's your decision. Nobody can interfere in that. But it's understood that those contractors who take or participate on these jobs, they must be expert, long experience. It's assumed, it's understood. So nobody demands that, but on structural projects, I don't care for finishes because finishes is not direct work. It is supporting someone from various protections. The main part is structural conducts, is structural framing or structures which are very important and which we talk about. If you can't provide durability or you can't provide strength, you cannot provide merit in whatever structures you provide, you deliver, it doesn't weigh, it doesn't value. And if you say you are sure of that product, everyone is sure, and you see users are happy with that, in a way they should be healthy, they should be enjoying this structure, and that's where requirement is. And construction can, you say, after process of bidding is over, construction comes into picture, and that's very important word. Because design was very important because of designs and calculations and related to previous history, but construction is current one. You have to construct, you have to use construction methods, your own methods or methods you have discussed with others. You cannot contravene those methods, and it's in interest of job. The method should be in writing somewhere duly approved by project in charge, or you can say engineer or whoever is there who is responsible for designs and construction, who shall take care of responsibility in future. And contract is number one responsibility. We know where even EPC contractors are they who handle designs also. So ultimate responsibility goes to contractor because it's the process of contracting. It's contractor's job. The contractor raised questions, answers, and by processing of bidding, one got award of contract. And then once you are expert on that project, you should know what project is, how shall it be moving, and how much it is moved. And then you can say, I am expert of that to some extent. You can't say a perfect, but expert. We have to be very careful about this. So we say designs, construction, and controls are very interrelated required sections for achieving from successful start to completion of a project. And that's a very important point we have to consider in real life. And if we don't consider this means we waste our time, we waste everything. So design, construction, controls are various interrelated required sections for achieving you can say from successful start or commencement to completion of a project, physical completion or final completion or mechanical completion or practical completion, whatever way till you have to move and you keep moving, which all must be applicable throughout project stages, with all works be smoothly affected. And this is basics of this, and we have to be very seriously understand this point. It's not my point or your point, it's project point, it's professional point. We have to give due value to this consideration. We have to give due value to this consideration because this is professional world. This is the way we have to do. It's not, there's no activity in isolation these days on projects. Every activity is important. We have to give this value to everything. That's why we say, and we can say, again I say designs, constructions, and controls are very interrelated requirement of required sections for achieving from successful commencement or start to physical, practical, or final completion of a project, which all must be applicable throughout project stages, with all works be smoothly affected, and that's basic requirement. Designs may be considered oversafe or optimum safe, but real construction involves actual expenses, money expenses, contract time, financial liabilities and buildings, professional reputation. It should be a certain motto, objective of an organization to apply good controls on project, and that's very important part. Good controls. You have to understand those controls, which are going to define that in coming time. Good controls means all controls. Controls on cost, controls on time, controls on quality, controls of working, controls on testing, controls on commissioning, control performance means all these stages have further subcontrols. So to keep in line to schedule, and schedule is very much, you can say, it's time control. Schedule or schedule, you can also call it time control, time schedule. And other schedules means list of materials, you can say, whatever materials you produce or whatever technology you use, that also imports control on them. And of course, planning is involved. Without planning, nothing can be done. And planning doesn't mean plan. Schedule is also a part of plan. And that schedule has a basis. That basis means it is quality oriented. Of course, it is quantity oriented. Quantity and quality are works. So you can say it is works oriented. What works we are going to do, what is objective of that work, that we have to consider. How does it move? Is it worthy of time control, or it's not worthy of time control, or it goes beyond time, and that we can say long leader it is. It has long requirement of time beyond even your job time, and that's why we can say being an actual part of controls. We have to study analytically and comprehensively. We can say when we study something, we think something, we first way is that we understand it through entire scenario, and we can say what we want to see. And then we start, it's a kind of, you as a summarized word. We say summarized writing. It's a kind of summarized world we can see physically. But if you're going to depth of inside, you'll find you have to study everything analytically, and that's very important point. When you say analysis is involved, means intellectual, or you can say foresight is involved for every item. Foresight for every item, not one or two, all. And that's what analysis says. We have to do analysis. Analysis conducting is very important. We cannot simply run away from that, even if you want to run away. Because then we have to explain why do we run away, means you have to conduct analysis of runaway, which is also very, very difficult to conduct. So better you conduct analysis of what you are doing. It's better. So it should be a certain motto, objective of an organization to apply good controls on project, and this means good controls on all activities you are going to do, you are going to perform, carry out, so as to keep in line to schedule, planning being an actual part of control. Cost escalation, time, budget, quality requirement, assurance, coordination, engineering as well as total engineering, and safety, risks, coverings, and delays, recoveries. So many points are here in that. Controls apply everywhere. It's not control, it's control of controls. When we talk of progress, we talk of work, means is it really work, means we have to compare it to schedule. We have to see what is schedule required, even if it's a part of design, means we have to prepare schedule designs as well. It's not only in construction but in designs as well. So we have to deliver this design 6 months or 1 year. What shall we do 1 year? We have to keep in mind when we start this, because this work is going to be started that time. So you have to be ready now. Likewise, every stage says you have to be ready for every stage. Even you cannot, suppose you cannot complete documentation, working documentation, it takes some time, so we have to be moving with analysis continuously. So we can say control includes progress, and that's an important point. We have to refer it to sub-controls, and that's why I have to say compare it to S-curve, for example, which means on the x-axis it says a time, and on y-axis maybe percentage of achievement of progress, earned value. So we can say it's a kind of S-curve that talks of progress. And of course, when progress brings itself or comes into question of project evaluation, it is cost that can tell how much I am going to pay you. And that cost is important point, and cost doesn't mean cost, actual cost means the contract cost. We can refer to any, whatever it is, because basic cost has to go, only profit margin can be with you or with contractor according to what we say contracts are. You can say rates have been fixed already, or can be analyzed and fixed, and there is no difficulty for that until we have, if you have material quantity known, if you have material rates known, a material rate of that one which reaches to your site, and that one you can say it includes raw material cost, includes mixing cost, or processing cost, or transportation cost, and then you get a raw material transported to site and it will be delivered to site, you can say. So that progress includes this materials, and of course this includes the cost. And cost, prices of an item can be multiplied by quantity of that item, look at cost of that, and keeping profit aside, so you can say. Then you can add profit on all items, some whatever it is. And because the cost is therefore a very involved factor, cost should not go waste. Cost, we cannot say today we did this building and after for some time it fell and everything crashed. It cannot be said that. So cost is very important item, because we deal with natural products, not on our own. You can say all materials involved in concrete, which is also very you can say natural type, because we mix all these ingredients and then we reach somewhere after a few days that this is ready for your use, and so many days have been over and we can start using this. And that's common process of humanity and every year. So progress, cost escalation is also very important, because there's a limit to that when you cannot go on escalating every activity. Few activities may be affected, or these can be taken care of, and we can say then time is important, budget is important, and quality requirement lies everywhere. As far as quality is concerned, we can say okay, we try control quality, at least whatever we do should be respectable. When quality, all detailed quality we can see later on. Now quality of systems and quality of material I'm talking of. I'm talking about the quality of materials. Your system already exists, and if quality doesn't work, system completely fails in quality, and quality fails means quantity fails. So we have to be very careful in understanding this point. Quality requirement as assurance, or we can say now it is no more requirement, and it's an exclusive requirement. Whatever you say, you have to do it, because your head of company is responsible for quality. Also in previous case it was not as such. In 2015 it has been added as such. So quality requirement, assurance and coordination engineering, as well as total engineering, and safety, risk discovering and delays. Of course we can say when question of quality comes in, it applies to all sections, all chapters, everywhere. You have to keep in mind that this is already, it's a kind of transport we have to use. We say it must be this one or that one. Same way as transport in quality, we have to transport quality from one part to other part of whole project, covering all parts in that. And that's why we can say it's a kind of total engineering, just like it's a kind of total system. I would say it's a kind of total engineering. Every engineering that relates to my project must be understood by education, by training, and if you cannot understand that in its total spirit, we cannot do that. And that's we say safety is also involved there. Safety, health and environment, which is a very important part for simple subject. Without safety people cannot work, without safety our machines cannot work. We can say safety is that type of fact. You have to eat food, you have to eat good food, you have to relax of course, so that your body is not monotonous. So likewise we can say there are so many points that are considered in safety, health and environment also, because health and environment is very important parts of projects. If health starts, you can say, being impacted upon, it impacts upon all. In that case you can say, of course, you can say people test on safety, and safety is very important part as far as environment is concerned, health is concerned, safety is concerned. And that point we have to keep in mind. We do not, I can't say we don't know anything about that, completely. We are still going on studying further how to get that. So safety is very important part, safety, health and environment. And then of course risks. You can say risks are involved. You cannot say risk is not involved. Or you say job analysis, job hazard analysis we can conduct. Job hazards, which also a part of contractor must be taken good care of. So safety tasks, safety risks are risks. Then if you know risk, what is the reason of that risk, and if you know all that, we can start diminishing those coverage on products or those skin areas which have been upset like this. Now we go further and say these are all integrated. Control is very important part. It's all integrated divisions. We should move in unison, we say. We should move in unison to achieve project delivery targets. And there's no one or two division, there's a group of vision depending on the type of place you have and what information do you have in your digital world, in your computer files, and you have to read them. Reading and learning, or learning in form of memories, even enhanced, though it's not necessarily enhanced. If you have a good mind, if you have patience, we can use same energies, but I don't know what's happening, but time is changing very fast, it's changed rapidly, and the fundamental of knowledge is not required by people, because further you have to have patience for a couple of years. Respect your kid to go up. Likewise, I said quality is growing here. Means for us, maybe quality once time is kid, and then it grows up and up, and one time becomes Middle East, and then you are like you, and it's that effort which you made earlier, those only stay in your mind, but we can't see where these are. It's just very important. Well-designed project will jeopardize. Likewise, there are all integrated divisions. We should respect them. We should move in unison to achieve project delivery target. And a well-designed project will be jeopardized during construction phase, and we don't want that. And because for what's the reason behind this? All we can say, jeopardize during construction phase from budgetary viewpoint. If we escalate budget or we overload it, and should not be given due required control application properly. Without organizing with full intensities, we can say without organizing with full intensities, keeping eagle eyes on project, we have to be very sure and strict in watching activities, or you can say respectfully and with you can say command. We can say these totals or these vendors move in streets and they sell their product, and that's important. That's an important point when some product ultimately comes into that. And a product is bad, you are considered bad. A product successful, you are successful. And that's a very important point. The success depends on your product. It doesn't depend on something else. And that point we have to consider at every level. Very, very important point, can't be taken for granted at any cost. We have to understand that point as well. So without organizing with full intensities, keeping eagle eyes on project and construction controls, no project can be delivered. No one can be delivered. We have to keep that point in mind. No project can be delivered in time and fixed budget. What it says then, first act of project leader, and I call every head of that project as leader by whatever designation we have appointed, that is different. But you can say verb is leader, you have to lead. First act of project leader therefore should be and must be to get into allotted budget. One should know what budget is. And if when you find problem in budget in beginning itself, you can ask for changes, or you can have your own parallel budget. And if budget is escalated, then to move project within its defined ambit is not easy. One should remember once money is lost, there's no possibility that exists to retrieve that lost money back. Money is such an item which cannot be recovered back. If you do not know where has it gone and how is it gone, if you conclude that no, it has gone right time and to right person, then there is no other way just to suffer. So you can say one should remember that once money is lost, no possibility exists to retrieve that lost money back. Analysis tool can be required to operate with complete dedication to carry out conduct controls. Controls are also very highly organized these days, and we have to use some analysis tool how to operate that control on projects. Very important point, we cannot live like that. I see many buildings constructed but nobody takes control, just construction on the way. They only know construction, they don't know reasons, and that's why mistakes are affected everywhere. Analytical tools should be used. You have analysis, you have to do analysis, you have some tool that can be required to operate with complete dedication to carry out conduct controls, and controls are a very important point. So this tool is very important for every engineer because this tool is not going to kill someone, it's a tool of help. Means you have to make sure whatever is done that was expected or it was in mind, it was not a part at the time. And you can't say that we open this and do it. We have to understand that. And if it's openable, we open it. We can then go further. All required sections related activities on both. See, we are going one by one again on these lines because of so much input always there. All required sections related activities import the total dedication. You see, we are using here total in every affair. All required sections related activities import the total dedication from quality, not equality, quality input within such disciplines in actions as well as in works. Whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review and to ensure constructability issues, which is very significant. If you think constructed is not achieved, constructability or buildability is not to be achieved, not being achieved by our efforts, there may be something transferred incorrectly between your class role which you have to investigate. That's an important point. Means we cannot simply leave it. That's important. Can be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions to achieve successful performance or ever activity to be conducted to avoid possible delays. Positive sentence complete is, I repeat, it can only be plainly said that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions to achieve successful performance of every activity or to be conducted to avoid possible delays. It's very important part of talk. We have to be very careful about its use. I'm feeling a little cold. Let me see. Temperature is coming down. That's why I'm feeling. It's now 11, not 12, so it has come for 1 degree, and maybe it goes down further because of early morning hours, and that's why humidity has also gone to 77. It's down. Dew point is 8, and that is a problem actually. So it is 8 degrees in fact. It's mixed up now, so it's difficult. So I have to check my clothes now because I'm feeling cold and it's really worrisome if I feel cold. So I should wear my jersey now. Hold on, no problem. And I was talking as number 12 point, we can say. This point numbers may change in future, but now it's that you can see on screen. It can be plainly said that engineering coordination is an only formula or a form, you may say, or active form. You can say active form, not passive one. If it's passive, it won't work. It's an active, and activity means your actions, coordinator's actions or engineer's actions. This can be plainly said that engineering coordination is an only form of formula or activity or discipline to reach workable, consistent and competent solutions to achieve successful performance of every activity be conducted to avoid possible delays. Then we can say, just for information, now we have just gone through basis of coordination. How does it operate? How it is valued? Is it really valuable at that point, or we are just thinking we are in doldrum? No, we should not be in doldrum. We can't be in doldrum. We have to be in the real world, and that real world is this. I'm just going to refer to you just for information, not for some, you can say, concrete answer. And that, as I reviewed, as I tried to search on, on system, on net, which you know is BIM, that is Building Information Modeling, a software meant for coordination. I'm not sure about that coordination, but whatever information I try to get, I'm just trying to share it in brief. It's not detailed information because I have not used this software, but just I checked it, and there's something that is what you may say BIM, Building Information Modeling. We usually call it Building Information Modeling, and it's really reliable one as far as knowledge is concerned, but we cannot say that it's everything, because just for information it is Building Information Modeling. Coordinator is a relatively ambiguous one, we can say. It cannot give us direct solved answer. It cannot give a solved path based that. So this BIM coordinator is a relatively ambiguous one, which may refer to a coordinator or several coordinators installed within a project or organization digitally, whose responsibilities could include developing and maintaining BIM protocols. Developing and maintaining BIM protocols and BIM execution plans and other documentation, ensuring protocols are adhered to defined requirements or criteria. Okay, that is, every software has certain protocols. Here we can say protocol is okay, we agree, that's not a problem. Why to argue on something which doesn't have any weight, or which argument doesn't have any weight, or doesn't suit him? So managing data sets, okay, we have to manage data we have. Now, coordinating stakeholders in terms of their respective roles within BIM process, that's also okay. Ensuring accuracy of models and data sets by establishing quality control procedures, and that's where we stand for. Ensuring accuracy of models and data sets by establishing quality control procedures, clash detection and clash avoidance. Wherever clashes appear, we have to find them. We have to detect them because they are intact inside. We have to detect and clash. Avoidance activity we have to do, how to avoid this clash, to change it to compatibility, or you can say to change into acceptability of solution, of procedure. And of course, preparing coordination, BIM coordination programs and progress reports. Then we have to say providing training and assistance to project team and explaining procedures and standards. These are all common. Nothing very specific in these points. Providing training and assistance to project team and explaining procedures and standards. Means first they should be told everything what you have to do in terms of procedures or standards which you have to follow. And standards are sound standards or international standards. Sourcing and maintaining model content is very important, where there are shared data and intermodal relationships. Intermodal relationships, making sure that these are recorded and monitored. So you can say sourcing and maintaining model content. Model content where there are shared data and intermodal relationships in existence, making sure that these are recorded and monitored all time. Coordinating data modeling and related management organization. Coordination data modeling or related organization management, liaising with design team and client, liaising with design team and client, coordinating handover of information at project milestones, Also very significant, you can say, coordinating handover of information at project milestones. Very, you can say, truly it is important, without which you may not say, it may not be helpful. And also BIM design constitutes coordination. You may say BIM design coordination. Design is process of creating a solution to a project. That's now definition of in this. Now so far we discussed for only very nominal points before, as we said in these points A to L. Now these are only points we discussed. Now I am referring to BIM design coordination that I noticed, that I noted from internet. What is this actually? I'm just referring to that one. It's not my writing, it's just a reference I am showing to you. It's a very important point, of course, and I try to share this with you, whatever information I have. BIM design coordinator, and here it says a serial is same, it continues, because separate one. Next time I'll change this M and maybe one I study again. So design is a process. Design is process. What is design? It tries to say in terms of BIM design coordinator. Design is a process of creating a solution. Of course, that is true. A solution means design is itself a solution of doing something. Something is required as a problem. We have to change that. We have to find a solution. Design is in fact a solution. Indeed, it is. Design indeed is a solution. We have to be very careful about. Solution in written form, solution in drawing form, solution whatever form. Design is a process, or you can say design is a process to create a solution for a project brief, or design is a process of creating a solution to a project brief and then preparing instructions allowing that solution to be constructed. Means design requires to be constructed and design has to be constructed. And if design is not constructed, there is no meaning of design. This design is only from academic part of view, that you can teach some students what is this, how it is designed, what is purpose of that. And if these designs cannot be, it's only for purpose of teaching, then it is not that level of design we are talking of. And there should be no requirement of any coordination. Because only design, it is learning stage design, like we do in engineering. Students do in universities. They learn designs, or you can say component designs, elementary designs. But here we are calling this design to produce, design that has to go to production. And that's the important point. So design is a process of creating a solution to problems. Problem, you can say, to project, you can say to the project brief, and then preparing instructions allowing that solution to be constructed, or thus whatever we generate that has to be constructed using that design drawing, specification drawing, or other sources and sources, references indicated in work or on contract. And we have to say what actually it is. Building design coordination, can say building design is typically a multidisciplinary process. It's sure. Every common sense person can say that. Every common sense ear can say that. Even if you are new one, just come out of university or institution, in form got education of engineering, responsible level education. I'm not going to name a degree now. Building design is typically a multidisciplinary process involving a number of different designers, such as architects, engineers, and so on, working together to create a single holistical solution. It's known to everyone. There's nothing new, it's just a reference line. The building design cannot be isolated. It cannot based on one discipline. It cannot be like that. Therefore, it's voluminous design for voluminous construction. And that's the beauty of this. Voluminous section with good elevation and sites to be created. So building design is typically a multidisciplinary process involving a number of different designers such as architects, engineers, and so on, working together to create a single holistic solution. Problems can occur. Problems can occur about where there could be certain missing information. That's we say problem. Until we go through all details, all requirements, we may not find reference, missing reference. We may not find that. If we can say problem occur, that occurring problem is due to what fact or what description. That description we have to discover, find, we have to relocate where it is at. And that you can say it's because of poor communicated information this defect could occur. Inconsistencies worked, and that's why it appeared, it affected. Inconsistencies between among documentation which could not be related, or somebody did not worry about the respective relations and just said, okay, we trust you, and that trust has broken to pieces. When your first attempt, you drop that person from engineering, education, from field. How can you say that person has learned everything? So the saying that missing information, poorly communicated information, inconsistencies between among various documents, poor resource allocation, poor decision making due to inadequate availability of information, and so on. There's so many reasons for that. Your design doesn't work uniformly where it should. Problems can occur about where there should be certain missing information, poorly communicated information, inconsistencies between and among documentation, poor resources allocation, poor decision making due to whatever inadequate information available, and so on. So everything be different, not what was expected. And we say these difficulties have become more prevalent as buildings have become more technicalities oriented. No building is technological free. Some technology is allowed everywhere in digital form or non-digital form. Therefore, technicalities oriented means very much oriented. Range of varying products and materials has increased. So we can say whatever materials we have, rate of increase is question mark. Range of varying products and materials has increased. Standards and regulations have become stricter, and of course, availability of a greater number of specialist designers. Of course, this or is wrong by error, so we'll check it. Design coordination is certainly a broad term. Design coordination is certainly a broad term. You can say good coordination. You may say that. You say design coordination is certainly a broad term describing integration of designs prepared by different numbers of project team to create a single unified set of information that can be constructed without any occurrence of clashes between among various components. So here we can say ability of great number of special designers, and that's okay. Now here is coordination, means design coordination is certainly a good term and broad term Describing integration of designs, that's very important point here. Integration of designs prepared by different members of project team to create a single unified occurrence of clashes, between you can say occurrence. Design coordination is certainly a broad term describing integration of designs prepared by different members of project team to create a single unified set of information that can be constructed without any occurrence of clashes between amongst various components. Here's effective design coordination. Effective design coordination can help to reduce costs. Delays and disruption that can be caused by problem on site, and it requires its remedial or abortive works or redesign. So that is effective design coordination. If you do understand policy behind design, why basement was approved. So we can say effective design coordination can help reduce cost, delays and disruption that can be caused by problems on site and require remedials or abortive works and redesign. In its broadest sense, design coordination can simply mean ensuring that designers understand about each case object. Effective design coordination can help reduce costs, delays and disruptions that can be caused by problems on site and need for removal or abortive works and others. In its broadest sense, design coordination can simply mean ensuring that designers understand about what they are responsible for, and in particular, who is responsible for interfaces and junctions between different design packages. That's also an important point. So we repeat, in broadest sense, design coordination can simply mean ensuring that designers understand about what they are responsible for, and in particular what they also we can say here that again I say in a more specific sense, design coordination can refer to actual process of ensuring that design solutions can be integrated, in particular mechanical, electrical and plumbing, MEP we call that, this science, which has all these disciplines permeate through entire building. That's a very important point. It permeates to entire building. You can say in a more specific sense, design coordination can refer to actual process of ensuring that design solutions can be integrated in particular mechanical, electrical, and plumbing operation form. MEP used MEP designs, you can say MEP designs, which as all these disciplines permeate through entire building and frequently source of coordination problems. This is also based on, we can say, as I said in this point, as in its broadest sense, design coordination can simply mean ensuring designers understand, ensuring that designers understand about what they are thinking, what they think, right? They are responsible for, and in particular who is responsible for interfaces and junctions between different designs and package. I'm saying interfaces is a very important term. It's not simply discipline form, it's internal, particular senses, interfaces and junctions between different designs, packages. And though we can say further than that, as we said before here, in a more specific sense, design coordination, as I say, can refer to actual process of ensuring that design solutions can be integrated. That can be done in particular mechanical, electrical, and plumbing disciplines, but in a more specific sense, design coordination can refer to actual process of ensuring that design solutions can be integrated, in particular mechanical, electrical, and plumbing, Wi-Fi. So you can say MEP designs, which all these disciplines permeate through entire building. That point we have to keep, permeate through entire building means the spaces, and frequently source of coordination problems. That's the point we have to understand here very frequently. And this is particularly true. This is particularly true for complex buildings such as hospitals, where there could be maybe a great number of buildings, services that are required to be installed in relatively confined spaces. Clashes may be hard or soft, we know that. Hard clash or soft clash, but we have to define that. And we can just think of that, what is soft and what is hard. Where route for pipe runs, where route for pipe work runs through a steel beam. It may also be soft. This is hard, If something's passing through steel beam, we have to be very, very significant about that, how to do it, how to avoid it. And there will also be soft clash, which can be result of construction tolerances. You can say soft clashes. And also too little space to install or maintain a component of building, very little space we have. lack of consideration, you may say, lack of lack of consideration of health and safety, also very important part. Lack of concentration, 56%. Okay. A lack of like you may say, lack of consideration of health and safety requirements. Too many works, too many workers being programmed to carry out works, too many workers being programmed to carry out works in same space at same time, and so on. Really, it's very important point. Very important point. Very important point, in fact, when it comes to this, is very important. So we can say, sorry, I have to take some water. Different soils can start. Clashes will be hard clash, for example, as I said before. Hard clash and soft clash, you may say hard clash, for example. We are root for pipe, as I said. So we say it depends on space availability, it depends on workers availability. There may be instances that space is limited, but we have more workers, and which doesn't work. It's maybe you have a chance to lose workers coefficient on that. Example, suppose we have some many activities to go on same floor of a building. The space on floor is limited. We have to handle material, we have to handle transportation of material from one floor to another floor, or we have some mechanical means, and there may be some form work going on. Also concrete is going on, steel reinforcement is going on. Or likewise in that area some excavation is also gone. If work is on ground floor. So there may be issues, means there is no circulation left, there is no clear movement left. And that makes us think, means there are restrictions on access, restrictions on circulations, number of workers, number of machines. And if it's complete mix up, which can lead to accidents, means it's a question mark. There may be clashes also, likewise. That is safety clash, and there will be technical clashes. Now we are talking of technical clashes. Technical clashes means it's not safety alone, safety is one part. Part is clash. Examples are many. A duct is to move. A duct was designed, size was designed, its roots were designed, but at that time structural information was not available, let us say not available. And HVAC engineer and site engineer did not care. The structural engineer did not seek any information. And what happens that a beam was designed of more size, you can say, keeping every structural requirements, and that's of course done. We have to keep depth better for resistance purpose. But we did not consider that some HVAC duct would pass in that line, and now it has to move, it has to pass through beam, and that is called a clash, because structural beams are not permitted to carry some or to allow penetration of ducts. It's not duct alone, there may be other services. Likewise, some trunking, electrical trunking, some copper pipe, water carrying copper pipes. Means beams, or you can say structural members, should be free of such services. And that can be kept only at time of coordination. And that's why coordination is affected, it is done. You cannot simply say, my design is this, your design is, go and do it. Yes, every discipline engineer can give design. Every discipline designer can give design. There is indeed no problem in that. It is duty of designers to give designs. And they of course give. But whose duty? It is to make sure that that is right. Means we have to be very careful. It's work of a station master, for example, who takes care of trains passing through, who must make sure that track is clear. If train station master says, I am not concerned with this, you think would it work? It's same way coordination is required. Coordination is required on works of all areas. Vertical controls, horizontal controls, space controls, surrounding controls, technical controls. There is no way you can avoid technical controls, and there is no way you can avoid space controls. There is no way. Every control is to be considered, and there should be no clashes at all. There should be no violation of bylaws at all. Should be no violation of discipline controls at all. That is what it's. We have to make sure that blames game will not work. That is first requirement. No blames game. No blames. There's no question of blames. Because those people, those personal, those discipline charges who are used to blame others, I cannot consider them professionals. They are not experts, they are just unaware of what to do. Blames cannot be imposed on others. Even if there are blames done by others, a competent person is competent enough to contain those blames. And that's what we say is professional person. See, how long can we move on shoulders of others? That's a point to be considered. We can ride once, twice, but we can't have a habit to ride on others. We have to keep this point in mind that we have to use your own legs to walk. You cannot walk on legs of others. So blaming others should be stopped. Clashes would come. It may be hard clash, it may be soft clash, it may be impacting clash, it may be destructive clashes, it may be work stoppage clashes, or it whatever name you can give it. It can be architectural structural clash. It can be services clash. It can be structural services clash. It can be whatever kind of clash. Finishing item clash with architecture. Finishing items clash with whatever. And for that, what we say, we have to understand coordination mechanism on projects. And that mechanism, somebody says it is BIM that can help. Somebody says this is work can help. Somebody says this, that all studies can help. In fact, I should say all studies can help. And that is studies of contract drawings, studies of shop drawing, studies of contract specifications, studies of what is required to be done. Are your shop drawings enough? Are your working drawings enough? In addition to that, we must have coordination drawings, coordination activities. And I can say in addition to BIM, it's not what BIM thinks is all time true. It is that whatever activities are involved, we have to conduct analysis of those and then do it. And analysis is an answer, analysis of activities involved, and then conducting coordination among those activities. It may be service activities like HVAC, air conditioning, lift, gas supply, medical gas, other gases in hospital services, where so many complicated gases are available, so many electrical items are available, so many other items are available. You mean to say services and whatever finishes or decorations appear in spaces all required to be considered, and this is not one stump job, it is continuous job. We can say internal services, external services, whatever services, whatever decoration items, and generally we know services run through ceilings and through basements and through walls and wherever, and generally concealed services are done, are installed, and this may be in wall linings, or you can say in partition walls and other walls, or in permanent walls. And there are so many ways to do that, and how this is done we have to decide that separately, but services must perform. And generally industrial project services run on surfaces, so that may not be much problem. But when it's non-industrial projects, it is a different way, different question, different answer. We have to consider it completely differently, and that is requirement of time. If we cannot understand that, we cannot do anything, and that's also very true. That services means services must be coordinated, and coordination applies to involved services. It doesn't apply to structures alone. If services can fit in without clashes, it's best to answer. It can be called best state. So what it says in this paragraph, clashes may be hard clash, for example, where root for pipe work runs through a steel beam. And there may also be soft clashes, which can be a result of construction tolerance as well. Too little space to install or maintain a component of building, lack of consideration of health and safety requirements, too many workers being programmed to carry out works in same space at the same time, and so on and so forth. You may say there are number of procedures that can be adopted, and appointments made to help minimize clashes and ensure proper coordination. There are a number of procedures that can be adopted, and appointments made to help minimize clashes and ensure proper coordination. Typically, where there's a multidisciplinary design team, where there's constituted a multidisciplinary design team, a lead designer should be appointed whose role includes integrating different aspects of design and respective interfaces into overall design. That is an important point, I think. Typically, where there's a multidisciplinary design team constituted, and lead designer should be appointed at top, whose role should include integrating different aspects of design and respective interfaces into overall design, amongst other things or other issues there may involve. And this is what we are saying. One is ensuring collaborative practices are adopted. That's very important. Means everybody should work in a collective way, in team spirit, and that is not your own company, but all whoever involved there, all agencies I mean to say, including consultants, including engineer, contractor, subcontractor, supplier, or whoever contributes to that activity. Coordinating quality control systems, and that's very important, because quality also is to be respected first, because we are talking of quality and coordination together. So coordinating quality control systems as well as safety also is involved. because there are so many regulations between various services. How many centimeter or meter this pipe should be from this pipe is HVAC pipe, this cable is electrical, this is trunking, or this water supply, this is fire. So we have to see that way also. Safety issue. We cannot mix up everything. It may be on vertical walls, or it can be on ground, or it can be underground, or it can be above ground or on ground. Coordinating quality control system, safety control system, adopting standard methods and procedures we have to discuss, and we have discussed many. What are procedures, what are methods, and we are discussing that in coordination too, because that's a very important point. Adopting standard methods and procedures. Coordinating preparation and issue of production information to contractors and suppliers. And that is also a very important point of communication. You can say coordinating preparation and issue of production of information to contractors and suppliers. And that should be given at time of invitation of quotations as well. Because this is how, if we can provide that at that time, though it's very difficult because we don't have complete information, but indicatively it can be said, it can be provided indicatively. I'm saying reviewing designs prepared by contractors and suppliers, and that is very important point, because contractors and suppliers do give their designs sometimes, many cases of their items which are proprietary items, which are patented items, and we have to review those designs. We cannot condemn them. We have to make sure that this fit into our requirements, and that's an important point. If this fit into project requirement, that's fine, that works well, and we can have meetings with them later on. And that's also a part of coordination if you are meeting, because we have to raise many questions that to answer. And there are many materials they supply. For example, this like PTFE bearing, for example, they supply some specific parts on specialized products. And those should meet our requirements, because sometimes we have to submit calculations as well. This property of material, this is not defined property, but this is research property, and this is claimed property by supplier or manufacturer. And then we have to design keeping those parameters into our consideration, and we say, okay, this point applies, this parameter given by this contractor or by this vendor is used in this calculation, and this satisfies our requirement. It generally happens in the EPC contracts. It applies in EPC contracts everywhere, and also applies on supply contracts. When they say this should be property of this material, it can be said, and it should be this property, and this should satisfy this item on this performance requirement. And that's where there are a number of different specialist contractors available or suppliers involved in later stages of design. And in particular during technical design stage, a design coordinator may be appointed to oversee coordination and integration of those designs. So very wide work it is. It's a kind of design and coordination work, or you may call it engineering work. Design and coordination is sometimes called engineering on project sites, because engineer involved in designs and coordination, actually that engineer is not involved in original designs, but in design reviews and design coordination, design review, and to work out, if required, further detailed work on those designs. And that's what definition of engineering is. You can say its engineering lies somewhere. In fact, original design engineering and original site engineering, in between lies coordination engineering. It depends on project. If it is project based, it depends on somewhere else. When it does many projects together, in that case it may lie somewhere else in our organization chart. So I say, there are a number of different specialist contractors or specialist suppliers involved in the later stage of design, means coordination stage of design, or working stage of coordination, and in particular during technical design stage, and that's where I say site technical inquiry formation. For example, engineering technical inquiry, for example, a design coordinating engineer may be appointed to oversee coordination and integration of those designs. May also call in some cases a design manager or design organizer or design leader may be appointed for this work at site level or project level, or at coordinating office level, whatever it can be seen. And its title is, in some cases, a design organizer or leader or manager may be appointed. And points are historically, it's not my writing, this is written by somewhere. Historically, design leaders and managers immersed in contract organizations, as they started undertaking a portion of design, which involved respective specialist subcontractors, respective specialist subcontractors. However, it has come to be used in a wider sense, describing a manager or leader with an enabling and coordinating role, but who does not act as a designer itself. I'm not saying coordination is design. It's a part of design, it's a part of execution, a connection to, you can say, like two cables joined together, and we can say cable joint or cable termination. It's not termination, it is cable joint, it is work joint, it is joint between design and coordination and work. However, it has come to be used as a wider sense, describing a manager or leader with an enabling and coordinating role, but who does not act as designer itself. Process of actual verifying design coordination still sometimes relies on manual techniques for cross-checking information, or you may say cross-checking, and later stage you can call it proof checking, with transparent drawings overlaid to identify potential conflicts. Computer-aided design can replicate this process on a screen, allowing drawings prepared by different designers to be compared and then clashes discussed. But generally, it is done manually, and that's more intelligent because a person remains on site. They know much more than what is available in computers. And when works go on in execution, there may be further clashes which can be related to of what we have inspected. Customer can say site-related clashes, which are many times more than what we see on drawings. Because of various chasing out, or can say various other issues, we can say these work on sites only, and this time there will be a long list of those clashes which your computer cannot give in terms of BIM. Building information modeling involves creating and managing leadership digital information for designs, construction and operations of built assets. Now, we are not talking of built assets here, we are talking of working assets, or we can say creation of assets. So building information modeling involves creating and managing digital information for designs, construction and operation of built assets. BIM can help ensure that collaborative practices are adopted and standard methods and procedures used, and the designers are contractually obliged to provide specific information at specific stages of a project, and that's a must. It says contractually obliged to provide specific information at specific stages of a project. One benefit of adopting BIM is potential for better avoidance of clashes. That is important if we can do it. Even using BIM, no harm. It can help ensure that there exists spatial coordination, not planar or linear coordination, spatial coordination or volume coordination. You may say space volume between different components. Means you have to move horizontally, you have to move vertically, and you have to move in all areas vertically and horizontally. It's called spatial coordination, and this is very much because so many risers, so many vertical pipes, so many horizontal services, so much, and sometimes, though it's not common, diagonal record, though it doesn't work. So in case in some program, it is called Avanti program, suggested that BIM could result in 75 to 80% savings in efforts required to achieve design coordination. I may not agree with that, but we agree with survey, no problem. But coordination cannot be done just that way. It can be done because you have to talk to people, that's better, rather than depending on their drawings produced, because machine is machine ultimately. Machine cannot replace our minds, that's also true. I am not criticizing it, I'm just accepting it, but I think it's better to talk to people. To talk to them can be much better than just leaving them behind and using software. However, there's another level in BIM 2, level 2 allows designers to work on separate federated models that you can say that are only brought together to create a single complete model of building at key stages. Building information model may also be broken down into volumes to allow more than one person to work on project models simultaneously, or to ensure that file sizes are manageable, or you may say not extensive, which state increases likelihood of a poor coordination. Then we can say clash avoidance and clash detection. Clash avoidance and clash detection must therefore be carried out as an integral part of entire BIS process, from defining standard methods, procedures, and establishing a BIM volume strategy through specialist design and creation of a virtual construction model, and should continue during construction phase itself, as models are updated with as constructed information. Clash detection software can identify clashes between individual BIM model and generate clash reports. However, this should not be relied upon as a fail-safe check, and should not be used to justify poor design coordination process. An information manager may be appointed to ensure that BIM information follows agreed protocol and that data is secure. However, they are not a BIM coordinator and have no design responsibility and no responsibility for clash detection or model coordination. These were certain points I tried to place in for information, because we have to consider all aspects of availability or available information or available tools that can be used for purpose of coordination. But again, I would say it is individual involvement, it is individual contribution from all disciplines and from all agencies which are involved in respective activity, that we have to think upon that, we have to collect information upon that. Software is done by someone who might not be given complete information. Experience of sites cannot be replaced by softwares. We have to understand everybody's experience is different, and you cannot generalize experiences. And particularly where structures are involved, services are involved, multitude of services are involved. Even software may not help, because software language says something, it reads something, and we understand something is going to happen, and therefore we have to be very careful about this. And I am sure that engineers don't draw themselves, and that's also a problem. When we say we talk of coordination, and it should be taken care of by coordination engineer. If you depend on other engineers for coordination drawings, or use this drawing and that drawing and superimpose one over other, it may be done by draftsman or by some other engineer, but you have to decide. So clashes can be seen, but everybody is not experienced in that clashes resolution. Only experienced engineers on sites or on execution or in coordination may be able to apprehend those issues on, you can say, work coordination, but to an extent design coordination is concerned, then design people have to be sure of what they do, and I'm sure they don't care for coordination currently. They don't care for what services are going to impact on this. Yet they call themselves designers and they design only. And that's the only reason that I try to include this topic of coordination and quality into domain of designs also, because without this designs are also not complete in real sense. Maybe they don't declare this, but it's fact that whatever work we do in design should be implemented on sites complying with all other requirements of quality, safety, and whatever you can say, safe work. And that's important point that everybody should understand. We go further on minute deliberations as we did before also. Of course, I'll go fast because it's already explained. Coordination is not clearly understood by many professionals and others in its real, in its right required spirit. That's true. We cannot deny this fact. We have to understand coordination, and it's the interest of every engineer to understand real coordination and not just coordination of your mind. Not coordinations within codes, but now we have got coordinations, you can say construction related coordination, work related coordination. We have to find out clashes where clashes can stop your projects, can stop some part of progress or some part of work, and that should not happen. And coordination means advanced study. It doesn't mean advanced university study, but advanced study. You have to keep yourself advanced of work, what work is going on. You have to see where plan works, how schedule works, and what works is coming next. And we have to do homework for that now, because if there are clashes, impact, we have to find solutions in whatever term. And particularly it's the responsibility of contracting company to keep very expert watch on this, eagle eyes, because it's responsibility of contractors doing job to make sure that designs are also right, though it's not design of contractors. Okay, it's EPC's job of contractor, but let us say it's job of others, then we have to give complete information to others. That's so important. So design coordination can be done at those level who are very expert in knowledge, highly profiled, and site construction coordination is done by those experienced professionals who have site long experience. Coordination is not one-day job, it's not two-day job, it's not three-day job. It's a job where technicalities are involved, complete information is involved, and therefore it's based on experiences of one. You should have a good knowledge of communication, you should have good knowledge of talking, good knowledge of conducting meetings, and good knowledge of material, good knowledge of procedures, good knowledge of whatever you see how. If you have not done in that, but you can refer it to, you can find solutions. You can go to study all specifications, every class of specification. You have to be aware of what it details, what details are missing or have not become yet, how many are coming, and does it tally with your requirement of time. So many issues are there. Fact remains that without adequate and efficient coordination in professional engineering, works cannot be successfully completed, and that is very much important point, because a lack of coordination means stopping the work. If there is no answer, you have no right to do wrong work or bad job. You have to seek answer from those who are responsible for that document to produce or to provide, and they should know that you're late and your inaction is going to consume time on this project, and that is duty of also coordinator to bring into mind of those who are responsible for that late coordination, late detailing. And if I could claim, it shall be right to admit that coordination failure leads to engineering designs and construction failures, already explained at length. For many engineers, the issue of coordination remains very, very delicate, and such engineers try to avoid involving in coordination complexity and just expect someone else should give final working drawings for work execution. But it doesn't work, because if engineers are not interested in coordination, they try to escape it. I don't think someone else is available. somebody else, or you can say anybody else is available. Of course, it's engineer's job. You are engineer in this profession. You have to deal with other engineering works, so quality, and your job is main because concreting is last job. Once services in such are the first fix, generally we call it first fix of services is done, and then we can say we can start working up concrete, but that is part of pouring. I'm not talking of pouring, I'm talking of coordination engineering. It's difficult part, technical part, everybody cannot solve it, only those people who are interested in it. And we're using input from during coordination meetings, technical and coordination meetings, we can say those resolutions can be redesigned, and we can say it's not to run away from coordination, but to involve with coordination. Those who run away, they have no confidence in them. So many engineers' issue of coordination remains very, very delicate, and such engineers try to avoid involving in coordination complexity, and just expect someone else should give final working drawings for execution. In fact, I've experienced that the engineers from around whole world scenario, majority engineers population do not have any interest, do not express or show any interest in working on coordination activities, and due to essential requirement on concentrating or focusing constantly on engineering and in-depth technical issues involved. Problems are not counted in numbers itself, but in considering gravity of situation, complexity and strong decision making related to whatever work items are involved. Because if we do not be serious, if you do not take or keep an eye on items to be resolved, which you cannot do yourself, but it depends on decision to be made by engineer. So whatever documents we have, there is no meaning if you give it ourselves. There's no such way. We have to give it ourselves. We have to involve it, resolving this coordination definitions for sure necessary to be understood for its real meaning, so that no mixing results in, and if mixing results in, it should be checked out. For facts results in, we have to know facts, what facts are. And then the question of sharing is a question of life and death of people with working with you. Coordination definitions for sure necessary to be understood for real meaning, so that no mixing can result in. And we can say mixing means a state of confusion in work, and state of confusion meaning indicates that right activity related to work cannot be carried out at right time. And this very important one, mixing means a state of confusion in work, and state of confusion meaning indicates that right activity related to work cannot be carried out at right time, and that can delay your project prosecution or project execution in its entirety. Also, if it is sequential activity, it impacts on further progress, or there may be some wrong decision or decision not taken in time. So that's very important point, and we have to take into consideration. We cannot just avoid that. So we may say that mixing should be avoided, and mixing means confusion. In construction world, in particularly structural and buildings constructions, no limits of drawings, no limitation of drawings and details or detailings exists. Even for a small building or a structure, categories of drawings and details, we can say drawings and details remain same as if it could be major building, and that's the point. It depends on design professionals. It depends on design professionals about how to apply drawings and detailings, so that construction personnel should not refer back all times, every time, for either confirmation or clarification of various issues involved. And this is very important point here, you can see, where coordination is failure, If I raise questions against my designer, whoever designed, and this detail is not clear, or this is not giving the true picture of plan. Here is what the specification says. If the designer is given information by site person may also be excellent. Depends on what person is, and that person knows what is coordination, and that person takes time and writes to designer, or through whatever means, whatever channel is there. If it's directly permissible, okay, or else you have to write to someone else. But generally this work, and nobody says don't do this, and we can say that we have to raise questions every time. If we raise questions every time, of course we shall get answers, but the question is why this has come. Just to clearly understand drawing, I have to raise many questions. This means drawing has been defective, or the designer did not have problems seen on site, no knowledge about that. If this person has no knowledge, then this person shall not bother about. So now it's my design, you follow, you can see the kind of arrogance comes in from both ends. But site engineer's responsibility, site boy's responsibility, that work should be done according to drawings, according to requirements, and that's what they are here for. But the questions come in, queries comes in, the crashes appear in, then it's doubtful situation, you can say. Why? Okay, one time it happens, but every time you have to write 4 or 5 times, you have to write, and you wait for answers, and those answers don't come, then you have to wait for again and again, and you can say it destroys project time, it destroys you can say efficiency that can be achieved within limits. That's why it depends on designing professional about how to apply drawings and detailing, so that construction personnel should not refer back all time, every time, for either confirmation or clarification of various issues involved. Coordination can therefore be defined in a way that all branches coordination can therefore be defined in a way that all branches of engineering and all disciplines involved in ongoing activity must be clearly described and detailed, so that no information is left out that could hold progress on activity or part of whatever activity. No information should be left out, or you can say this definition is very simple. Coordination can be defined in a way all branches of engineering and all disciplines involved in ongoing activity must be clearly described and defined or detailed in, so that no information is left out that could hold progress on activity or part of whatever activity. This is a kind of formal definition. Maybe you can check, you have a different definition, but ultimate aim is same. If even one small information is held without having adequate details, or is not formally confirmed, activity can stop, or it shall be carried out based on either correct or incorrect knowledge possessed by site team, which work could be considered in contravention of what designing team contemplated for. Consequently, it shall be certainly leading to cause formal errors. This is very important. I repeat it. If even one small information is held without having adequate details or is not formally confirmed, activity can stop, or it shall be carried out based on either correct or incorrect knowledge possessed by site team. Site team has also knowledge because they have work experience, construction experience, and they may have other references from other site, and if they think this designer is wasting time, this designer's drawings are not good, not, you can say, the cooperative drawings, don't provide information, and once they try, second time they try, every time it happens, then maybe they stop writing to designer because this is waste of time. They write formally only, and they use their own mind to do job. In that case, it's very dangerous also. It means that It can be dangerous, Why it says dangerous? Because small information is required. You're unable to give that information, trying, and you have to ask for again and again every information. And which stops work and which work could be considered contravention of what the designing team contemplated. Consequently, it shall be certainly leading to cause formal errors on site. It also remains in fact that no subject or no branch of coordination engineering is available for imparting professional education at any either diploma or degree level, and even if it may be considered up to doctrine level, you can say, doctorate level. Absence of inclusion of this very significant subject within engineering program is not welcome. Explicitly indicates that and evidences that education professionals do not understand value of engineering coordination discipline. It is not actually defined as discipline. We have to use it as discipline. There is no other way. Such people are very rare. But there are few people who can understand what we are saying. That's where point lies in, important point. More can't be called educationist fault. Okay, we have said that. It's not their fault. We can say that. More can't be called educationist fault. For they don't remain active in older to it. You may say it can expand its vistas to unlimited areas involving many disciplines in one branch of engineering, and also importing various branches of engineering depending on what class of works are affected. We have also seen in era of coordination activities when there used to be no electronics related technologies, or we now call it information technology, but wherein lot voluminous works were carried out on civil, electrical, mechanical and architectural engineering coordination. And that's very common, you can say. Even in that era, works of coordination were very much time consuming due to fact that even drawings were not manually done. So this all previous time, we cannot compare it to current time, because patience people had, time they involved themselves, one person involved on designs and coordinations independently, and they knew what was to be done. Still electricity was there, mechanical was there, all was there, but quality was also there, which may be not available now. So therefore we can say with ease, coordination engineer would have been appointed had incumbent professional been experienced on considerable good size, and whosoever professional having just one engineering discipline knowledge could not be successful for efficient working on site, because coordination is not listening, it's not just writing or just referring. It is different, because you have to think that this is not right way. You have to pay something temporary and thinking that's right one. That's not requirement. We have to feel this point very easily. And it's not that much we can go further on this. Coordination is coordination, it can be avoided, it's to be done, and that's important point we have to be careful about. No way to avoid it. And we can say coordination engineer would have been appointed had the incumbent professional been experienced on considerable sites, and whosoever professional having just one engineering discipline knowledge could not be successful for efficient working on site, and progress consequently either marred or errors caused. Such unhelpful situations force professional engineers to work long hours, to have firm grip of design details and correlated one discipline with all other disciplines one by one, of course, consuming considerable work allotted time. And understanding of coordination, definition, and respective descriptions makes certain differences on works. Certain differences on works. We may not call it teamwork for sure, because coordination cannot be done effectively by team, but certainly by perfect getting through all related details available of schematic design as well as on other documents, and of course professional market prevailing conventions or so-called good industrial practice. Okay, good industrial practice, and that we have to see about that. I would say that let's go this way and see how it works is better. We have to continue this system of quality and coordination. Today I try to involve with BIM, which is of course is good for something we have been here. We have to understand that cannot be avoided, and also that an understanding of coordination, definition, and respective description makes certain differences on works. We not call it teamwork for sure, because coordination cannot be done effectively by team, but certainly by perfect getting through all related details available of schematic designs as well as on other documents, and of course a professional market prevailing conventions or so-called good industrial practice. And we'll jump from next time here. I'm not going to do this. We are saying our title being quality project works, and we have talked of quality, safety, and communications, coordinations, all in one. And these are very important for every engineer. Even if you are a structural engineer, you have to relate to designs on site, how they understand designs, how they relate it to their work, and how queries can be raised on site. And those points must be very clear. Otherwise, it becomes a question mark, means coordination is defective, and we don't want effective coordination. In fact, we want soluble coordination. We want a coordination that can solve problems. Problems are understood by way we have our potential. It cannot be misrepresented at all. We have to know this fact. That's very important fact. Coordination engineering and communication engineering are under same title. We can say these affect all works, particularly where complexity of works arises. For example, I'm not talking of ordinary coordination. I'm talking of very complicated coordinations, like in high rises, like in multi-stories, like in couple of stories ground, or you can say in other areas where works are very difficult, where services are integrated into the building in such a way that we cannot isolate that. It's really wonderful the way to think about that. If we can think that, we can solve many problems of coordination. We can say, in fact, we can solve many technicalities which have been wrong, which have been, you can say, ambiguous. We have just taken for sake of taking, and with that I can say, okay, fine, we'll look back again, see, all right,